Hello students. In the last video we showed you how to find the unknown length of the side of any side in a right angled triangle using the Pythagorean theorem. In this video we're going to look at what's called the converse of the Pythagorean theorem. Now the converse of a theorem basically just takes the theorem and flips it around. So here's what I mean by that. The Pythagorean theorem says in triangle ABC, if C is right angled, then C squared equals A squared plus B squared. The converse of the Pythagorean theorem says in triangle ABC, if we know that C squared equals A squared plus B squared, then we know that ABC is a right angled triangle. So with the converse of a theorem, if the theorem says if A is true, then we know B is true. The converse says if B is true, then we know that A is true. So we can actually use this to figure out if a particular triangle contains a right angle or not. Now, if you think back to the first video, if you watch the introductory video on the Pythagorean theorem, the Egyptians used this particular piece of rope to help them build the pyramids. So what they did is they took a piece of rope, they put knots in it that are equally spaced, and then tied it into a loop. And they knew that this particular piece of rope in that configuration, that this always gave you a right angle. And they were able to use that to make sure when they built the pyramids, they were building the pyramids and the angles in the corners were right angles. So let's go ahead and see if the Egyptians were correct. Is this triangle actually a right angled triangle? So first off, we need the side lengths. Well, 1, 2, 3. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So those are each 3, 4, and 5 units long. So what I'm going to do is write the Pythagorean theorem, C squared equals A squared plus B squared, but I'm going to put a question mark above that equal sign, because at the moment I don't know if it actually is a right angled triangle, and therefore I don't know if this relationship actually holds. Okay, let's put the numbers in. Okay, I should have done this before. That's C, that's A, that's B. Always label the sides. So is it true that 5 squared equals 3 squared plus 4 squared? Well, we don't know. Let's put a question mark there. Pretty simple to figure this out. 5 squared is 25, 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So both sides are equal, and therefore it is right angled. So the converse, using the converse of the Pythagorean theorem to determine if we have a right angled triangle is pretty easy. You pretty much write the theorem, put in the numbers, that should still have been a question mark, put in the numbers, and simplify each side. Oops, I think I've just gone one too many. Give me a sec. Okay, that's where I want to be. Okay, let's find out if triangle LMN is a right angled triangle. So to start with, we've got to figure out which side might be a right angle, and we find the longest side, and the side opposite that is potentially the right angle because it's the longest side. So I'm going to put a C on the 50. It's the longest side. A is the shortest side. B is the next shortest side. Write Pythagoras' theorem. C squared equals A squared plus B squared. Question mark. We don't know if this actually is a right angled triangle, and therefore we don't know if this relationship is true. In place of C, I'm going to put 50. In place of A, I'm going to put 30. In place of B, I'm going to put 40. Now 50 squared, well 5 times 5 is 25, plus a couple of zeros. 3 squared is 9, plus a couple of zeros. 4 squared is 16, plus a couple of zeros. And if we add 900 plus 1600, we get 2500. And we can say, therefore, angle L is a right angle. Now, some of you might have been clever enough to say, well, this is really just a 3, 4, 5 triangle multiplied by 10, all the sides multiplied by 10. And it turns out that's always going to be true, that if you can take a right angle triangle and multiply all the side lengths by the same number, the new triangle will also be right angled. And that's a property of what we call similar triangles. Okay, I want you to have a go at this one, please. Is triangle XYZ a right angle triangle? So stop the video, have a go, and restart the video once you've finished. Okay, welcome back, guys. Okay, now looking at the three sides, the 13 is obviously the longest side, so that gets the letter C. A is the shortest side, and B is the 11 centimeter side. Write the Pythagorean theorem, but again, we don't know if it's true or not true, so we put question mark above the equal sign. Substitute. "13 squared is 169, 5 squared is 25, 11 squared is 121. And again, we have to keep the question mark there because we're not sure if this is true yet. Well, 120 plus 20 is 140, 5 plus 1 is 6. And therefore, triangle XYZ is not right angled. So there you have it. Using the converse of the Pythagorean theorem to determine if you have a right angled triangle is pretty straightforward. Okay, in the next video, we're going to actually start looking at some further applications of the Pythagorean theorem.